All right. Well, thank you so much for coming. And I appreciate the GraphQL Foundation giving me an opportunity to speak to you. I recently was an architect at a major global financial institution who unfortunately will have to remain nameless for various reasons. And I want to talk to you about that experience and tell you a little bit about how GraphQL factored into that solution. So it requires a little bit of background information. You need to be aware that there's about 50 years of modern regulatory financial regulations that impact everything that happens at a financial institution. All the things that you see on this timeline had some impact on data management or data governance within those institutions. And if they failed to do those things, it was an existential threat. They could be put out of business. There's approximately 300 global regulators who might require up to 10,000 different financial reports or regulatory reports to be filed by these institutions. The most important one here is the one in 2010, which was the response to the 2007 global financial crisis. And this is the thing that really kicked off the modern era of data governance requirements within financial institutions. Now, this was capped off in 2020 with what they call the Basel IV Accords, which kind of finalized the requirements for that. Basel is a committee that most major countries participate in that drafts standards for financial regulations, and most of these 300 global regulators draft their regulations from those Basel Accords. So this Basel IV Accord required lots of granular identification of data that was ultimately used in the calculation of various risk metrics. It required them to be accurate and complete, and they had to prove one way or another that that information was accurate. I love the head nods. Someone in here is experienced with this, perhaps this young man right over here. So I was given the unenviable task of looking at this very, very large shared service organization within this global bank. It was the largest shared service organization in the bank. It comprised a third of the employees of that bank. And information exited that organization, went into lines of business, and in some cases directly into regulatory reports or reports that went to key executives or board members. The problem was that sometimes that information wasn't correct, and they were trying to figure out why that was the case. This was clearly some sort of systemic issue. This was not a small issue. So this encompassed maybe roughly like 100 key stakeholders, about 1,000 systems were in scope for this. And this took months and months to analyze, lots of quantitative analysis, meetings with those key stakeholders to sort this out. Some of the preliminary conclusions that came out of that was, which are probably not unsurprising if you've been in this situation previously, siloed data production. There were at least 3 major enterprise-class data warehouses that were involved. There were many, many smaller data producers, and they all operated independently. They had their own tech stacks, their own processes for engaging them, their own mechanisms to access data from their systems. In addition, we also looked at historically other examples of consolidating data across this institution, and it was not a pretty picture. For the most part, these programs consumed lots of money, like tens of millions of dollars. In one instance, it was $100 million and a 5-year effort to build this consolidated data warehouse, trying to solve similar problems. And I would say that people did not have an appetite for spending that kind of money or spending that kind of time to solve this problem. That's going to be an issue the entire time. So keep telling me when it blinks off. So the other thing that I think wasn't surprising is that there was a lot of redundant data. And setting aside the reasons for redundant data, the redundant data itself was clearly an issue. This was part of the problem. the data consumers themselves were really struggling with working with this particular shared service organization. It would take months to get data feeds set up from this organization. They had to interact with multiple teams in order to do that, and it was not a pleasant experience. And then finally, this entire project was actually sponsored by a data governance organization who was trying to figure out, because they were responsible for this information and the quality of this information. And I would say that this organization was very, very manual in its approach. There were attempts to automate, but not exactly particularly successful. They also wanted to view themselves as a value add to the organization, but that clearly was not the case. They were more of a kind of a necessary evil. They kind of kept people out of jail, but no one really wanted them around if they could have avoided them, right? So a few conclusions from those initial observations. There were inconsistent data quality metrics. Obviously, that's sort of a problem if you're trying to assess data quality. However, I'm just going to dismiss that for the moment. There are different solutions we came up with that, but they don't have as much relationship to GraphQL. So let's sort of ignore that for a moment. There was sort of a lack of what I described as semantic modeling. So in many organizations, you'll find that these individual groups have a real commitment to doing data catalogs and expressing the information that's available from them. This organization did not have that sort of history. That's not something they did. They did have lots of different ideas around data modeling, and they did different things to try to determine what information they might be providing, but no one provided that sort of single semantic layer that expressed in business terms, this is the information you can get from my organization. And that meant there was no common language to discuss data across this organization, which was a problem in and of itself, but it also kind of exacerbated an understanding of data ownership. Who really owned what bit of data and was responsible for it? The other thing I would say is that it was very clear that data producers were clearly the bottleneck. Too much work was going to them, and a lot of that work wasn't really value-add work. They shouldn't have been responsible for the work that was being pushed to them. So in a sense, what was happening is very narrow requirements were getting these data producers. The view was, and what we concluded was, is data producers need to focus on reusable data products. If they were focused on an audience of one, they had a big problem. They needed to create data products that multiple groups could make use of. And then finally, all of this, what we concluded was, because of this lack of focus on data reusability, it was creating, and I have another slide that'll explain this better, but it was creating this sort of ball of yarn of all these data feeds that were sort of emanating from these requirements that were coming out. And this became the problem. Our view was that it was because we didn't have the right kinds of services in place. If we'd had more services that would allow data composition from the consumer side, that would have allowed the data producers to focus on this reusability idea. So let me give you maybe a different take on that. We described it ultimately, and this really resonated with the leadership at the bank, and it was an unusual conclusion. Most people would have doubled down on going back to those data producers and saying, you're screwing up, you need to fix your problems, right? In this case, we came up with a different conclusion. We said that the way we were using data, right, was actually creating the environment that made it so that data producers could not be successful. And we needed to rethink the entire thing organizationally and from an architecture and services perspective that would change this environment so that data producers could actually focus on their job and do a good job, and data consumers could be satisfied with that result. So I'll give you kind of an example. I would say that most data consumers were sort of associated with one or two domains. They had an affinity with that domain. Most requests would go from a consumer to that domain. That domain would say, sure, here's your data. But half the time they'd say, actually, we don't have all that data. We need to go get that data from some other domain. Or they would say, we're not allowed to do that. You need to go get your data from this other domain. Then the consumer would sort of build systems on their side to create this sort of data set for their particular purpose, right? That all seems fine once, but this was happening 50, 60 times a year. Imagine systems, which I calculated, lasted about 7 years. So this is happening over a 7-year period. What is the end result of that process happening 50, 60 times a year over a 7-year period? What happens is that all this interdomain traffic starts to overwhelm the organization. And they start spending all their time on all this other activity and not really satisfying the data consumers. We calculated this. We concluded that about 2/3 of activity was wasted. And that if we could solve that problem, we could cut out 2/3 of the cost in the data producer's environment and in the consumer's environment, related to data, of course, not all their costs. So the other thing that happens with this, though, is the consumers start to pick up that some of this information is a little fishy, right? That this thing that's described one way here seems like it should be related to this thing, but it's different. Now trust is lost, and this becomes a major issue. They no longer trust this data, and they start building out their own mechanisms to look at that data, figure out if it's accurate, and in some cases, they cleanse the data and create another variation of the data, even a worse outcome. And then finally, I mean, data governance is just sort of, like I could go into 4-letter words here, but they are absolutely like screwed at this point. They cannot really deal with all of this. And they just start pouring in people and money trying to wrangle this situation and solve, right, this problem that they're encountering. Does any of this seem familiar to anybody who's been in a similar situation? A question? Or you're just saying yes? Okay. I just want to make sure that this wasn't a unique situation that I encountered. Okay. I didn't think so, since I'd been doing this for about 30 years, so I figured I was more or less on point. So look, the first thing we thought of is, how am I doing on time? We're doing okay. So this is a really big project. We wanted to come up with some sort of Uber architecture that would guide our thinking, right? And this probably was naive and not exactly the right way, but we somehow thought that data mesh and data fabric were sort of these competing things that we needed to look at as to build this sort of Uber architecture that would guide our thinking, right? So because it was somewhat misguided, I'm just going to get all the way to the end and tell you that we chose data mesh. Data mesh became our organizing principle. We thought that the way it really emphasized decentralization of data, the way that it described data products we thought was brilliant, and we just thought that this thing really mapped easily into our organization and could be a great way for us to think about it. Data fabric was also really interesting. It emphasized this idea of a unified data access point, which we thought was also very interesting and correlated with some of the things we're trying to do. But we concluded that it was more of a very more prescriptive solution that could actually complement data mesh and not really compete with it. So basically, we put data fabric off to the side because that isn't something we were going to focus on. Now, as I said, if you think this is sort of a conceptual architecture of a data mesh environment, and I like to say that every large organization lives in a data mesh, you just might not know it. So because it kind of maps to the real world, to be honest, the way it's described, the only real issue is, are you doing a good job at it? And the way I kind of come to that conclusion is, without any intention of doing this, we could easily map our organization into this diagram. And that meant we could use this kind of concept as a way to measure whether or not we were adhering to the principles that were described in the data mesh articles popularized by Jean McDougany. The other thing is she had some principles in that article that we thought would be really good ways to measure our organization. So we did that, and I'll show you what happened. First, oops, I wasn't going to tell you that. Oh my gosh, let's start over. Okay. Decentralized data domain ownership. We were already decentralized, so we thought we were doing pretty good there. The only real question was, did it have the right level of autonomy? Were the boundaries drawn really ideally? Maybe not, but we very generously, as you already saw, we gave ourselves an A-. Data product. This was in people's lexicon. They were starting to think about it, but no one was really producing data catalogs and so forth that might memorialize a data product, but people were still thinking about it. And let me just point out for those who aren't familiar with the concept of a data product, it's kind of a retail analogy. So the idea is you should be able to name the product, you should be able to know its ingredients, you should be able to know who manufactured it, you should be able to sample it, you should be able to know its price, you should be able to acquire it relatively easily. If you meet all of those criteria, you have a data product, and it should be discoverable. So unfortunately, most people think publishing a data catalog means they have a data product. You really need to measure yourself against all of those other criteria that I just rattled off. So in the end, we very generously gave ourselves a C because we started the journey just about a little bit, right? All right, now, oh, darn it, I keep giving you the answers in advance. Wow. Anyway, domain agnostic self-service infrastructure. We already had lots of enterprise shared services that did this. You can think about this as like a public cloud, going into Azure, asking for a VM, that's self-service infrastructure. Domain agnostic, I think that if the infrastructure itself is very metadata driven, is a good tell that it's domain agnostic. We already had some of these services. I think lots of people are on the journey to provide services along those lines. We weren't finished with that journey, so we gave ourselves, as you already know, a B-. Lastly, federated computational governance. This is the least understood, in my opinion. So this is about interoperability of data products. Can I correlate, aggregate, select consistently and reliably at scale? Right? This was absolutely not in our thinking. It didn't occur to us that this had any, that this was useful, but in our attempts to try to measure ourselves against this, we concluded that we really weren't thinking about this at all. I'm going to just stop right here. Are there any questions that I can answer for anybody? Is all this making sense to everybody? Okay, cool. All right, so with all of that, we established key objectives for our project. I won't go over these in detail, but you can see that they're very heavily driven by the scores, right? So this implementing, what did I call it? Implementing services to composite reusable data products obviously was one of the key objectives, and it related back to the scores from the earlier examples. This was sort of our bigger statement. I'm not super happy with it, but I'll just repeat it. Create a data use strategy with architecture, standards, and centralized self-service infrastructure in order to reverse the negative trajectory in the data delivery model and to create positive reinforcing loops to self-correct time to market and data quality. That's what we wanted to achieve in English, or as close to English as we could come up with. So now we're into solutions, like what can we do to accomplish this stuff? We looked at API gateways. Kind of didn't really work from a data composition perspective. There were ideas in there, and we could have used API gateways, I think, to solve this, but it just seemed like too much effort. We also looked at query engines. We really liked these. These were really phenomenal products that could really help particularly older organizations that needed to produce data products. They could do a lot of the heavy lifting, eliminate some of the movement of data, but we didn't think that it was a complete solution because it didn't provide the unified semantic layer that we thought we needed to define to actually achieve the objectives that we were describing. We really liked GraphQL. We had some experience with it, and we thought that the GraphQL schema definition language, the standard itself, was a great way to explain holistically all of your data products and their relationships. And we thought that this would be a good way to go. But we had a lot of questions about tooling. So we saw, just to reiterate the point on GraphQL, we saw that it was very metadata driven. We saw that as very, very useful. We were very mindful of what was going on in the DevOps world with things like Kubernetes, et cetera. And we saw this drive towards metadata as sort of pivotal and something that we could leverage. And we thought GraphQL sort of meshed with that. We really liked the standards committee. We liked the standard itself. I like to describe it as a Goldilocks standard, right? Not too hard, not too soft, just right, right? It really engaged the community and allowed them to provide, creative solutions. Didn't restrict them too much, but it provided good guardrails around it. And by the way, the community itself impressed us tremendously. So thank you to all of you who are part of that community. And then finally, as I said, data mesh, we thought just fit the real world. You're in a data mesh whether you knew it or not. And we thought that if that were the case, GraphQL just filled this need in data mesh. And so we just thought it just sort of made sense to us. So ultimately, we implemented something that was called the supergraph architecture. We didn't call it supergraph architecture initially, but eventually, Tom Gopal, the CEO of Hasura, has written extensively about the supergraph architecture. I've written a couple of articles about it myself, and this is what we implemented. We did some additional things where we augmented it by classifying data domains into things like reference-derived domain, transaction domain, et cetera. But the main issue with the supergraph architecture is it is very metadata-driven. It is very little code involved in getting it started. So that means we could quickly spin this thing up. We could access our data products with composition, selection, and aggregation. We could. The other interesting thing about it is it's very bought into OpenTelemetry, and it spans all the way from the data request down to the database. And that means that we could get really phenomenal feedback loops going that would explain data usage that we thought were extremely useful in representing to regulators and others the results of our operations. We also saw it as a strategic investment that we should do first, not last. Like some people might be tempted to say, well, let's fix all our problems and then put this capstone at the top, right? Since we were sort of in a brownfield situation anyway, we thought that we should put it in first, connect it to existing domains, and then use it as a mechanism to start this flywheel going so that we could mature our data domains over time. And then lastly, it was absolutely impossible to convince each of these individual data domains who were very focused on data products to build APIs. But we could convince them to say, you need to supply this metadata that explains the data that is in your organization into this supergraph. That supergraph can then take that, validate it, and then deploy it on your behalf. And so that meant that we had very low barrier to entry to get this thing going. So this is I got to improve this graphic, but this is sort of my mental model for thinking about data domains. And everything on here is almost optional. You just have to have some control, and you have to have some data that you're delivering through that control point. But based on mission, scale, and complexity, you pick the products and these areas that you want to focus on in your data domain. The reason I'm bringing it up here is I had to change my mental models to incorporate two additional things. I added this idea of a unified semantic model as a key control point within this domain stack. And I added this additional service, this multi-protocol data access layer, as a service to operationalize that unified semantic model. So this was the key change that I made in my mental models around how to design a data domain.
Where are those two?
Oh, they're the blue ones. Sorry, they're right here. Okay, and sorry, yes, you'd have to turn your head. I did add one other thing because we were very impressed with these query engines, and we had some like older environments, and this was really a great kind of easy step to modernize them. And also, some of those environments weren't prepared to serve data, right, through the supergraph requests. And this provided an abstraction layer for them to be able to do that easily. So with that, I'll just say we got faster time to market. We had lower costs in both our producer and our consumer environments. We had better evidence of our data operations that we could share with key stakeholders. And we had simpler integrations because it was very heavily metadata driven. And if I have time, do I have time? A little bit, 2 minutes, 2 minutes. Let me, and I'm the last one, right? So you guys can stay a couple extra minutes, right? So let me give you an example of how I can take all this metadata and create really individualized persona experiences that are driven by this metadata. So let's say a data steward. A data steward really wants to probably interact with a data catalog. I just wrote a few lines of Python code to take the metadata from the supergraph and populate a data catalog. So let me walk you through kind of a persona journey with a data steward. So a data steward might be interested in these things, subgraph, supergraph, et cetera. This is the technical metadata elements of a supergraph that I put into here. But he's probably interested in it from a different angle. Like he might be interested to understand, where's all my personally identifiable information that I have to track, right? He may be interested in where's all the confidential information and what technical metadata elements are associated with that. Now, right, this sort of meets him in his space, right? Instead of trying to get him to think about it from a more technical perspective. He might want to look at it from a subject perspective. So this is the Chinook database that I use. So he might look at music content. He might say, I'm interested in albums. He might say, now I can see that this album as a topic is associated with this metadata, technical metadata element. I may now want to look at the lineage of this technical metadata element. So I could look at this and I could say, so I can see that this is related to this data connector that has these columns. It has this meaning that's attached. Let's just follow this down and see if I can get some lineage info. So now I'm looking at this individual column. It says here that it flows into this thing right here. This thing, as it turns out, is a field that's part of this object. And this object is served by these queries in the supergraph. So now I have all this lineage that he can easily kind of click through and see how data is flowing through our organization, expressed in the way that he's interested in looking at this information. But if I'm a developer, right, I want to look at it differently. So you can use, in this case, we used Hasura, which was part of this supergraph architecture. So I can look at this DDN console that Hasura provides. Same thing. I can say search by album, but now I get more technical information. And I can do things like query this information to see if it actually is providing the information that I as a developer am expecting. And then finally, let's look at it from a support person's perspective. And I don't have a Grafana dashboard, which would be the ideal way to do it, but there's sort of a mini version of here in the Hasura console, so I'll use that. This is their insights version. And the last operation I did is just represented here. And so you can see here that all of the information from the request all the way down to the database is here, along with all of the metadata associated with this. And if you put this into a proper dashboard, you could do a lot more with this as well. But what the end result of all this is, I've got a support person, I've got a developer, I've got a data steward, and they're all speaking the same language. And in my experience, that doesn't happen. And that translation is where everyone gets really screwed up. On top of that, I've now delivered data composition, selection, and aggregation services, and I've got data producers who can actually focus on their jobs. This was all put into production. It's in production today. They're actively adding new data domains to it, and might be a little early to completely call it a success, but these are the early sort of takes on it. Any questions from you guys? And I know we're over time. Well, oh, yes.
If you had your time again, you said that you started off with brownfield, as kind of like, not a proof of concept, but, a pathway to adoption. Do you think brownfield is the right way, or if you did it again, would you say, hey, let's try greenfield, brand new project, and use that as a path to gaining traction?
I mean, it just wasn't even feasible in this particular situation. You've got hundreds of millions of dollars and 20 years of history in thousands of systems, right? It's sort of like the idea of this big consolidation project that I said wasn't feasible. Again, you needed to come up with incremental ways to solve the problem. And again, the amount of risk as you make changes is just enormous, right? So you have to be really, really careful in the way you sort of construct your architectural solutions. Yes?
If you were able to identify some data as being redundant,
Mm-hmm.
how did it go politically in terms of telling the people who own that data that they could put it aside or not keep it anymore? Was that a challenge?
Because in GraphQL, we can advertise, first of all, people are relying on that data potentially, right? So it just can't go away, right? So the first thing is you have to use the observability elements to determine if that information is being used first. Okay, the second is you have to advertise that it's going away. So you have to deprecate it, right? Put a time limit on it, then start monitoring it. And then once you get to the point that everyone knows about it and you can see the usage going down, you usually have one or two problems. Then you'll have to like dig in on them and go like, you have to stop using this data, right? And here's the alternate place for you to get it from, right? Does that give you a little insight? Yeah, it's also, if you think about REST APIs, usually they version. And I don't think that works well at all when you're thinking about data APIs because you're at a level of granularity where you just want to turn off one thing, turn on another, right? You just can't do it at that API level effectively. And this provides a much cleaner, more sane way to go about doing that. Any other questions? You keep nodding your head so much. I'd love for you to ask a question.
What were the time frames like for this project?
This took 18 months till went to production. From the moment they asked me to think about it to the moment we put it into production was 18 months. Yeah.
Who are the ultimate consumers of those GraphQL endpoints? What are they used for?
Yeah, so for the most part, there's sort of three main consumer types. So there are approximately 500 regulatory reporting organizations within the bank, and all of them could be potential consumers of this, right? But there's also executive reporting or other reporting teams that are looking for the same data. And then in some cases, this data flows into operational systems, right? So basically it's applications, it's dashboards, and it's executive dashboards, and it's reg reporting. Those are the three types of consumers.
So they're mostly pulling aggregates and summaries.
Except for the reports, often that's true. For the applications, they often want more detailed granular data. Any other questions? Thank you so much for your time. I really appreciate you willing to listen to me.